On the screen, we have the last year's question from the 2015 question paper. This time around, they don't tell you to find the percentage purity. They actually want you to find out what mass X you've put in there. Now, it's the same kind of idea. But they give me a few other tips. Watch here quickly. One, they tell me that I take a mass of fertilizer, which is ammonium chloride, and that ammonium chloride I dissolve into sodium hydroxide. Okay, so I dissolve it into sodium hydroxide, and then sodium hydroxide is in excess. Now, and then they give me a balanced equation. They tell me in the ammonium chloride, the fertilizer, I put in sodium hydroxide. But they say this is in excess, this is the problem. Now I need to understand my problem. And part of the problem is I now have to find how much sodium hydroxide do I have, because they gave me the volume and the concentration. So what am I going to do? I'm going to use that formula again of the sodium hydroxide. Now watch just how clever this one is. And then what do I do? And here's the question. Calculate the number of moles of sodium hydroxide in which the sample is dissolved. So this is the kind of thing that is happening that you've got to sort out now. Now watch carefully. Let's say I've got, if you watch my screen from the top quickly, you will see that I have some of the, that's right, I've got some of the ammonium chloride. This is what it looks like. This is ammonium chloride. And let me just add some water to my sodium hydroxide. So I just have a little bit more. And now I'm going to pour some of my fertilizer ammonium chloride in there. And then I'm just going to stir it up a little bit. And all I know is it all dissolved. It's crystal clear. But what is missing now is that there is too much sodium hydroxide in there. I don't know how many grams I put in. Too much sodium hydroxide. Problem. What must I do now? I'm going to find out how much fertilizer is in there. Well, the fertilizer has reacted with the sodium hydroxide, but there's some sodium hydroxide left over because they say there the sodium hydroxide is in excess. So there's too much sodium hydroxide in there. Now maybe I should draw the idea for you so that I can get you to understand it much better. I was hoping that I have another sheet here, but I see I don't have it here now. Let me just try and then innovate. Right, let's go. Let's see. Let's say I have a beaker there, or a flask, sorry. I'll just draw it that way around. I'll draw a flask there. Okay. And now in this flask, I now have some sodium hydroxide. Okay. I'll make the sodium hydroxide blue or purple, just for that matter. I'll just draw it that way around. That's my sodium hydroxide. Then I introduce a little bit of fertilizer, and the fertilizer dissolves. The fertilizer dissolves in there, and let's say that amount dissolves, fertilizer dissolves with the sodium hydroxide. So I'll do that for my fertilizer in there. Can you see here that I have a little bit of excess? This is my excess of sodium hydroxide that I need, my excess sodium hydroxide. Now, how am I going to know how many grams are in here? In other words, what's the mass of that? I can find out if I know how much sodium hydroxide I have used. Then I know in the ratio between the fertilizer, NH4Cl, that ratio, if I know the ratio is 1:1, no problem. So my ratio is 1:1. So which one must I find out first? I must use the sodium hydroxide because this one was X, the unknown. You get that? So I must find out that one first. And once I know that one, then I can easily deduce this one, get my number of moles, go to mass, problem solved, and I get lots of marks. But here is the real problem. I need to find out how much do I have in excess sodium hydroxide. And how am I going to do it in this case? I am going to find out by adding that to hydrochloric acid. And then I will neutralize this excess. This will disappear, and I'll know exactly what's going on there. That is the plan that we want to use. So let's go through the plan step by step, quickly. Remember now, my fertilizer is in here. I don't know how many grams of fertilizer. I can only find that out once I know how much moles of sodium hydroxide has reacted with it. But I must first get rid of the excess sodium hydroxide that's in here by using hydrochloric acid. That's right. I'm going to put in hydrochloric acid there, and that's the way I'm going to do it. Nice way here, nice trick. Let's go again. Unknown X in here. Too much sodium hydroxide. Neutralize the extra sodium hydroxide. Then find out the moles that's left in here. Yes, by subtraction. And then so I have moles there. We'll get rid of excess moles. Then I find how many moles remain. I take those moles into mass, and then my problem is completely solved. Let's go and find out how we do it on the screen. Let's find out the original number of moles of sodium hydroxide I've got. So I'm going to use C times V for the sodium hydroxide. I just put the numbers in. What is it again? How many? Oh yes, I see now. For a moment I didn't know exactly how many moles of sodium hydroxide I have here, but now I think I can do that much better. I see I have had 100 cubic centimeters. That's my volume of sodium hydroxide. I divided by 1,000 to make it cubic decimeters, and my concentration, with my concentration 0.1, I put it in there. So at the beginning I have 0.01 mole of sodium hydroxide. Good. Now I know what I have right at the beginning. Now I must take it 2 or 3 steps further, because now I need to tackle. Now, what's my next step again? I must get rid of the excess. How do I use it? How do I do it? I use some hydrochloric acid. Let's find out if that is the trick. Let's see on the screen. Now they tell me during a titration, that's right, during a titration, 25 cubic centimeters of excess sodium hydroxide solution is titrated with 0.11 mole of hydrochloric acid. That's a nice idea. That's right. And at the end point, that means when the indicator changes color, I found that I used 14.55 cubic centimeters of the hydrochloric acid. Wait. Hydrochloric acid concentration 0.11. Good. Hydrochloric acid volume 14.55. I've got volume. I mustn't forget to divide by 1,000. And then I can easily get my number of moles of hydrochloric acid. That's right. And once I've got my moles of hydrochloric acid, yes, that's right. Once I've got my moles, how much moles I've used of hydrochloric acid, I can find how many moles of excess sodium hydroxide was there. That's the plan. So I use standard to find unknown. Always standard known concentration to find the unknown. That's always what I do. Very easy. Let's quickly see. And here we go. So now we say, I am going to find out the moles of hydrochloric acid by using the information, the data given to me. And that means it's that number there. Where is it now again? 0.11. And that means I take that one and I divide it by 1,000. That's right. I take 14.55 and divide by 1,000. I get that number, and there's my mole of hydrochloric acid. Now what am I going to do with that mole of hydrochloric acid? Okay, if that is the mole of hydrochloric acid, because it's 1 to 1, that means that must also be the number of moles of excess sodium hydroxide in 25 cubic centimeters. Right, everybody got that? Let me just quickly repeat. So if I have 1.6 times 10 to the power minus 3 moles of hydrochloric acid, that means the excess that I have taken out of here by neutralizing it is also 1,6 times 10 to the power minus 3. Yes, but that was just for 25 cubic centimeters. Now I must still get to my 100 cubic centimeters by using proportion. That means I must multiply by 4 because I've only neutralized 25 cubic centimeters. I must neutralize the entire 100 cubic centimeters. That's the plan. Let's see what we do next.